Hello all, welcome to the Bluetooth technology part 4 session. Uh, in the previous session, we have discussed briefly what is beacon. Uh, we discussed that beacon is a Bluetooth low energy device which sends out periodical advertisements. And we also came to know that these advertisements, using these advertisements, we can use it in many use cases, in many applications such as indoor locationing, people tracking, and finding our lost, misplaced items and so on. Okay, so for today, let us see one use case, indoor location by using beacons. Okay, so for this application for indoor locationing, the basic hardware which we require is, first hardware is beacon, the second hardware is smartphone or a tab or a laptop which is BLE enabled, and then we require a software. We require an indoor locationing app if it is on mobile, and a PC software if it is on a PC. Okay, on the right hand side, if we see, there are two images. The first image just shows a diagrammatical representation of a building. So suppose we want to know where exactly we are within the building, because it is indoor and GPS will not give us the accurate location. So in these cases, how do we use beacon in these applications to get the exact location where we are, where we want to go, and so on. Okay, there is one vendor, Estimote, who provides beacon, and he provides a stack so that people can develop application on top of it. The second picture represents how Estimote beacon looks like, and just a snapshot of the PC application. Let's move on. Okay, for example, we want to do indoor locationing of a big factory, or maybe hypermarket. So for our application, we have divided the whole factory into 6 regions: region A, B, C, D, E, and F. Okay, so in each region we have placed a beacon. For example, if you see the beacon A, denoted by a blue color, circular blue color one, is beacon A, and then beacon B, NC, ND, ENF, and so on. So these are positioned such that they can capture a particular area or a particular region. Okay, so suppose we want to find out where we are exactly with respect to this area. So what do we have to do is, first we need to get an app installed in a mobile. Okay, the indoor locator app. Okay, and what it does is, once we open the app, it starts scanning in the background. Okay, so it will start scanning for beacon A, beacon B, C, D, E, and F, and so on. Okay, while scanning, there are a lot of parameters which are received. So one parameter is UUID, MAC address, RSSI, and distance. So this UUID and MAC address is unique for each beacon. So using this UUID and MAC, we can differentiate which device is advertising, which device is exactly advertising. Is it A or B or C? So that is used for identification. UUID and MAC is basically used for identification of the device. Okay. The third thing what we can receive is RSSI. RSSI stands for Received Signal Strength Indication. The value is the value is received in terms of dBm, decibel megawatt. So it says us how far away we are from the beacon, or it says how much is the strength of the signal. So depending on this signal strength, or depending on the power of the beacon, so we can determine the distance. So there is a formula which we can use to determine distance from RSSI value. So once we determine the distance from the RSSI value, then we'll come to know that, okay, we are in range of beacon A, or we are in the range of beacon B, or in the range of C, D, E, F, and so on. So once we open the app, in the background, the app scans for all the beacons which are available in range. Okay, and it lists down all the parameters: UUID, MAC, RSSI, distance, and so on. So once it has listed down all these parameters, it starts estimating where exactly the mobile sees. It senses where exactly is the mobile away from the beacon. So for example, consider we are in location B. Okay, so the beacon B has a UUID. For example, it has a UUID XXYYZZ and so on, and it has a MAC address AABB and so on. And the RSSI, so suppose if we are in the region B, the RSSI value will be, maybe it will be minus 40 dBm, minus 50 dBm, which shows that we are within 1 meter, 2 meters, or within 10 meters of range of this area. So depending on this, then we can accurately say that, okay, we are in region A, B or C or so on. Okay, and using this information, suppose we are in B and we want to go to area C. So depending on this information, so because of this scanning and calculating the distance, we'll come to know how much far we are away from A, how much distance we have to go to C, how much distance we are away from D, E, F, from how much distant away we are from the entry, and how much distance we are away from the exit, and how do we navigate from one area to other. So these kind of things the indoor locationing app gives us. Okay, so if we see here, so the screenshot which we saw in the previous slide, it is background scanning and analytics and all what is happening in the background. So in the foreground, what it does is it signals us that, okay, you are in area B. Okay, and then if suppose if you want to go to area C, you are this much meters away from area C, you are this much meters away from exit and so on. So this was a brief example how we can use beacons in indoor locationing. So moving forward, we can use this same concept of indoor locationing for people tracking also. So suppose in this area, beacon is static and mobile, beacon is static and the mobile from which we are scanning, it is moving. Okay, in some cases what happens is mobile is static and the beacon is moving. So these kind of other use cases also we'll be discussing in the further sessions. For now, that's all. Thank you.